Hello everybody and welcome to this presentation. I am Dr. Ifrikita Daju, Space Mission Analyst and Specialist in the interaction of the space environment with materials and devices. I'm also the founder of Nanosatellite Missions Design, and today I'd like to tell you about the company, what it does in general, and more specifically what it does in terms of trading. First, I'd like to tell you about what we address as a company. In Africa, which is where we focus our efforts, there are many countries new at space, so new entrants in the space sector. As a result, there is a shortage of skills and training, and those who design missions generally struggle to define them and are not necessarily sure exactly who is the best person to partner with. Adding to that, there's the fact that some of the space capabilities are underutilized and the satellite data available is very underutilized at the moment. So what do we do to address this? Besides matchmaking and consultancy, where we basically help people find the best technology partners, the best strategic partners for their space endeavors, and we also answer various questions related to space projects where, for example, one needs to design and build a concurrent design facility or train engineers on how to use a concurrent design facility or set up a technology roadmap related to space science and technology. These are things on which we consult. So besides the matchmaking and the consultancy, we provide nanosatellite platforms where we basically do the entire phase 0 and phase A, mission analysis and design, which is the definition and feasibility study. We provide spacecraft design and assembly, integration and test, as well as mission operations. On the satellite engineering training side, we train engineers on how to perform concurrent design. There's also hands-on CubeSat training and hands-on operations training. On the satellite data intelligence side, we provide raw data. If we're given a data set, we provide analytics and mining, and we also design artificial intelligence for optimization of mission operations, and we also do data cross-correlation to infer new meaning from data sets that are seemingly unrelated. All this we manage to provide by associating with strategic partners, and I'll mention them at the end. So, why does this matter in Africa? First of all, let's talk about the strategy and policy. The African Union recognizes that it is necessary for Africa to have a better control of its space infrastructure and have a better autonomy in things like security, infrastructure development, health, disaster management, etc., etc. It's not closing itself to the world, but it needs to have better autonomy. And one of the events that marks the fact that this is a bit more pressing than it was before is the establishment of the African Continental Free Trade Area Agreement, which makes of the entire continent of Africa a free trade area. This means that there will be a lot of intracontinental infrastructure development that needs to be monitored, and it is necessary to optimize on the level of autonomy of Africa when it comes to space infrastructure and satellite data. Why else is this important in Africa? Well, because of the political will, and political will is so important and can be seen in the number of space agencies that are currently operating in Africa. In fact, there is the African Space Agency's custodian of the African space policy and strategy, and overseeing the different national space agencies to ensure that their activities are in line with the continental strategy and policy. And Cameroon might be the next national space agency, given the recent activity in Cameroon related to feasibility studies and relevant studies of a space agency that started in 2019. Why else is this important? Well, because there is a market. a 7 billion US dollar per annum market, and it is quite significant. In fact, over 14, right, of the 32 satellites, in fact, more than 32 satellites launched by Africa were built by African engineers. And some of the ventures, the business ventures in the space sector are in engineering, communication, propulsion, and ground support. And there has been more than 200 million US dollars invested so far. And this is significant. This is significant because it means that there is an industry. Of course, it is growing, it is finding its way and shaping itself, finding an identity, but it exists. What does it mean concretely? Investors are putting money in business ventures, which means there are new companies, which means there are jobs, which means it is possible to be trained in the space sector and find a job in the space sector in Africa. This is very important. This industry is growing, and in fact, it's not about whether or not the space sector in Africa will evolve. It is evolving, and it will keep evolving. The real question is, what role will the Africans play in this evolution? And it is important, therefore, to realize that it will happen. We just need to do our part, right? Do our part to contribute more Africans to the party, and we do this through training. The first step is training, and not any kind of training. Training that is appropriate to help the vast array of skills and expertise already in Africa to transition, if need be, into the space industry. And we therefore have different training packages, and the outcomes of these are that those who go through our training have a practical understanding of space mission design. They have an understanding of how to engineer for the space environment. What does this mean? I mean, there are really, really exceptionally skilled engineers, scientists, entrepreneurs in Africa. And the list goes on, right? And they build technology to use on Earth. They already have skills that are needed in the space sector. One of the bridging elements is that they are designing for a different environment, for the space environment. And we provide training that allows them to understand this environment and be able to design technology that will survive in space with all the constraints that come with it. They'll also have a practical understanding of how to put together a satellite using concurrent design approaches with the tools that go with it. These are approaches that allow you to save a lot of time and a lot of money and come with designs that are more reliable. It puts those we train in a competitive position to access the space industry, be it to pursue further studies, be it to do a switch of careers, right? And of course, we give certificates as evidence that people have gone through our training. There are advantages to go through these trainings with nanosatellite missions design. Well, the first is our network, right, and strategic partnerships. That is that comes as an advantage to those who go through our trainings. Those who go through our trainings will have access to CNES mission analysis tools for free. CNES, Centre National d'Études Spatiales, is the French space agencies, and they are also strategic partners, and they make these tools available for free provided you're trained, and we provide these trainings. We also broker internships, right? Because we know the industry, we have contacts in the industry, we can broker internships and helps future interns to find companies and motivate their applications with the fact that they have gone through our training to access some internships. We also broker future studies and degrees and certifications, because sometimes you have those who want to study further in the space sector, but they don't know where to go. We can help them find the right university, the right institution to pursue further studies in the sector. And of course, there is a community. There's a community in the African space sector, and we help students to be part of this community and be active in this community. The networking is priceless. Right, so let's zoom in a little bit on mission analysis and design, which is a holistic and concurrent approach. When we're looking at a space mission and we're trying to define the objectives of this mission, and then later on do a feasibility study, what we do actually is to propose different mission scenarios that will meet the objectives of the mission, the proposed objectives, right? In an attempt to really pin down what the mission needs in order to meet its objectives. So it goes through mission simulations where we simulate different scenarios and we visualize it, right? Once we have this, we then look at how we can use a concurrent approach to put together a satellite, right, to meet these objectives. So we produce technical budgets as outcomes of the concurrent design of a satellite to meet the mission objectives. And once we have done that, we have practically at the same time the environment simulation, where some tools are used to establish the radiation environment and thermal environment that the satellite will be exposed to, and simulate the effects on the sensitive technology on board. And while this is going on, there's an entire financial engineering process going on to ensure that, from human resources to planning to frequency acquisition to testing and operations, etc., etc., and of course, if there's a business case for the space mission, making sure there's some cash flow model, to ensure that this mission will be profitable. Then there is the operation optimization, where the ground support is designed, the operations is designed, and artificial intelligence algorithms are designed to make sure that there is the right level of onboard autonomy if need be, and that data is utilized optimally. This is done with a certain number of tools. Some of the mission scenario simulation tools are SimuCIC, Celeste Lab, and VTS, all made available by CNES. Spacecraft design, the concurrent design of satellites is done with IDM CIC and IDM View. The environment simulation can be done with tools like Omer, FastRad, and ECORS. In-house, we're building financial engineering tools as well as operations optimization and AI, artificial intelligence tools. Right, so when we go through concurrent design training, what we do is we take a case study approach. We either take a hypothetical mission or an actual mission, and we analyze it in a methodical way, where we evaluate different concepts and architectures for this mission, and we design the spacecraft using state-of-the-art concurrent engineering approaches and tools to produce at the end technical budgets like mass budget, power budget, link budget, data budget, etc., etc. And this is done with all of the players on board basically simultaneously. In a concurrent design facility where you have centralized simultaneous design capabilities, you can have the decision makers, owner of the project, project manager, you have the financing, those who provide the money, the sponsors and the investors. You have the mission analyst, systems engineer, you have subsystem specialist, ADCS engineer, power systems engineer, mechanical engineer, etc., etc. You have assembly, integration and test engineer, software engineer, artificial designers, financial engineers, all working together in parallel, everybody having the big picture and designing taking into account each and everyone's constraints and interfaces. This is so crucial because it saves a lot of time and a lot of money and produces much more reliable initial designs. One of the important things we add to our process, which is not traditionally done, is inject some artificial intelligence to address two main questions. How can we provide more decision making and autonomy on board to simplify operations? Basically, what level of onboard intelligence will reduce hardware complexity and reduce operational complexity? Basically, for example, if I'm trying to detect fire, can I have intelligence on board that upon taking an image will be able to tell that there's a fire and just broadcast the information that at longitude this and latitude that, there is a 90% probability that there's a fire of so and so dimensions? Rather than waiting to get to the ground station, downloading the image, someone sits on the ground, analyzes it and decides that there's a fire, by that time it would have had time to burn whatever it had to burn. What we also ask as a question is, if we cross correlate existing satellite data, data that is already collected from the ground, any ground sensor, or maybe some any other data collection, health information from patients, etc., etc., and we cross correlate with some satellite data, can we really simplify a space mission in terms of the payload, right? So rather than taking 3-4 sensors on board, can we complement by simple data analysis what the mission is trying to collect and reduce the number of sensors on board to just one, so that it just complements the data that's already there? These are some of the approaches we take when designing space missions, and we train engineers on how to think this way, where they find the optimal solution using data analysis and artificial intelligence algorithms. So I would like to show you, some demo examples of what, once you finish defining and simulating your scenario, and you have a first 3D model of the spacecraft that is supposed to carry out this space mission. What does it look like in visualization in an actual concurrent design facility with everybody around the table looking at it? To show this, I'll take an imaginary mission, that I thought up to illustrate this case. So imagine that you're trying to measure some data from ships at the Atlantic near Cameroon, and also take some images in Yaoundé. So suppose your ground support is in Cape Town. So this is the satellite acquiring mission commands from Cape Town, and then establishing contact with the ships from which it needs to collect data. It collects the data from the ship on its way, and as it approaches Cameroon, turns its camera, points Yaoundé where it was instructed to take images, collects the images as much as possible, and towards the end it was also instructed to take a quick look at the border with Nigeria because there's some activity there. So it does take a quick look at the border with Nigeria, and when it's done with that, as we will see now, there we go, it carries on and wait for the next visibility, right? So this is an example of what a scenario visualization would look like. Then we go further, as I showed in this diagram. At the table also there are those who will do the environment simulation. So suppose that around the altitude and the orbit of this mission there is a specific space radiation environment, and suppose there is one very sensitive technology that we can model, right? Can model as a diode. It could be a diode, and we model it to see what happens if there is a neutron impact on this diode in terms of single event effects. In fact, with a course, you can model your diode and see, right, really see what happens if a neutron impacts this diode, as you can see in this video, right? So here you have your diode with the substrate and the potential, and there we go. You have a neutron impact and it creates two ions, and these ions go in two tracks, right, across your device. In this simulation you can see, right, the potential drop along the tracks and what happens with the electric field at the edges, right? And this is you actually watching what this impact does to your device, how the potential drops, and what it means in actual life is that you could actually be watching a bit flip, or a zero becoming a one, or a one becoming a zero where it did not have to be, right? So you also see the fact that such effects, your device can recover from them, as you're seeing the potential recovery of this device, right? So you can examine at a very, very deep level of detail the impact of the environment on your technology on board a space mission. So I took these two examples to show you a little bit of the kinds of simulation and analysis that we perform for clients, and on which we train engineers, right, and students, so that they're able to do it themselves. Right, so in terms of strategic partnerships, we work closely with Centre Spatial Universitaire at Montpellier, FSATI, CPUT FSATI, and both of them have very interesting experience in terms of nanosatellite design, because both of them were the first in their nations to build a CubeSat. You know, FSATI was the first to build a CubeSat in South Africa and in Africa, as a matter of fact. CSUM were the first to build a CubeSat in France, and both have an array of successful missions still in orbit. There's Amaya Space, which is the company that was a spin-off company from CPUT FSATI, currently building a constellation to put in orbit very soon, right? So working with them, we're able to provide, nanosatellite platforms to those who would like to build nanosatellites. In terms of engineering and training, we have the same partners, from nanosatellite platforms, as well as Delphia and CNES, who put to our disposal really interesting tools that allow to do concurrent engineering, and that allow to simulate the effects of the space environment at the level of the devices, right down to diodes and transistors inside, integrated circuits, some of which are utilized by companies like Microchip to understand how radiation affects their technology. This is cutting edge stuff used by the biggest, to develop their technology and to develop their space missions. In terms of satellite data intelligence, we're working with Drone Africa. Drone Africa, with lots of experience in developing artificial intelligence algorithms capable of doing things like identifying plasmodium inside blood samples, counting specific objects specific moving objects from among other objects, doing image analysis in video streams in real time. So we're partnering with them to provide artificial intelligence algorithms and data intelligence for satellite data. Thank you very much for your attention. If you wish to talk more, with us, here is how you can get in contact with me. You can visit the website, you can email me directly, or you can call me on one of these numbers. There is always one of them working depending on where I am, between South Africa, Cameroon, and France. Thank you so much for your attention, and I look forward to hearing from you. Keep well. Bye bye.